Welcome back to the ABAP Objects Refresher. This time we're on Module 4, and we're going to talk about a very, very important concept in object orientation that is called polymorphism, and specifically about interfaces and how they relate to classes and how you use them. So what is polymorphism all about? Basically, the word means polymorphism having multiple forms. Or you can also say, you can assume to have multiple implementations of a class or something that have the same abstract interface, look the same on the outside, but are totally different on the inside. Now you can say, oh, I have an if statement inside and switch between implementations, but what you really want is to have, for instance, say a class implements a interface, a feature in this way, and another class implements it in another way. So you can replace the whole class, and but the client has to not know about it. Or, for instance, you want to offer a future extensibility, so you want to be able to later, you think ahead and you want to replace the class implementation and still keep the rest of the system the same. Some examples may give you a better idea, and this is, for instance, let's assume you want a generic save method on each object. So each object you want to be able to save, and let's say in this case you want to say just save it to the database. So you want to have an object, any storeable object, and call save your data to the database. Now if this is efficient or stupid, that is another matter, but let's assume we want to do that. The trouble is, of course, that each class has a different, it is a different class, and so either you have to implement this method on each class, and you could do that with that name, save your data to the database, but what reference do you use? Because the reference is typed, and how, you can't know a car and a truck and a customer and an order, they will all be different classes, so how can you make this work? It doesn't. Another case you can imagine is, let's say an archive manager, you want to be able to archive objects in or data into some optical archive store, and the archive manager just wants to talk to any object and just say archive yourself, and maybe also pass in a stream or whatever, or let's say it assumes where to do it, but you want to call the object in a generic way. And so you can ask the archive manager, archive, and then basically pass in the archivable object, or you can have the archive manager register all kinds of objects and then call them, but the problem is the same. The archive manager needs to talk to all different kinds of objects in a uniform way. And a third idea is, example, maybe if you have any kind of vehicle and you want to have a refuel method that you would want to be able to call, and it doesn't matter which type of vehicle it is. So this is the kind of thing you want to be able to do, and the question is how you do it. And object orientation, so OO languages typically offer two features for this. And the first one we'll talk about now, and this is called interfaces. And this is something similar to classes in the sense that there is an interface definition, there is an implementation, and there is client code. So let's look at it, how this is done. First of all, the definition is like the definition of a class. That it means, if you look at the code there, it says interface and the interface name. So LIF is also a naming convention, local interface underscore. Public interfaces would be IF underscore because you don't want the L there. And then you can define methods, attributes, whatever. Anything you can also do in classes, except you don't have a public, private, or protected section. So without the section, everything else is pretty much what you can define inside an interface is the same as what you can define in a class. So in that way, all elements are public with respect to the interface. Now let's assume you have defined in this case, a refuel method in the interface. Now a class, going down, LCL car vehicle definition, you can say, I implement an interface. And you do this by the interfaces statement. So you can typically, as the name already alludes to it, implement many interfaces, just like methods and attributes. And so in this case, we implement LIF underscore vehicle. And then what happens is, it means you have to implement the method. And the method name is a combination. So if we switch now to the implementation, so you look at LCL car vehicle implementation, and you look here at the method, and you see the implementation name is combined by the interface name, LIF vehicle tilde refuel. So it's combined because you could have multiple interfaces with the same name of say methods, and you want to be able to keep them separate if you want to keep them implement them separately. And so in this case you have to then, of course, define an implementation. So in the class you specify the code, and in this case add the leaders to the current tank level. Now the point is that each car, in each vehicle object, let's say class, we have many of these, has to implement this interface themselves, and so they can do it differently. So in one case they can have this statement, in another case they can have another, an airplane. If we count it also, well, it doesn't, not really a car. It's not it's, well, it can be called a vehicle, I suppose. An airplane might do something quite differently if it to implement the refuel method. So the idea is you define the interface, you implement it in a class, and then you can do something because the interface is also in a reference type. You go down here to the client code, and we see that there is a data, any vehicle, type ref2 LIF vehicle. So now we have a reference variable of type interface, and we have the car to, in the classical sense, that is the class reference, a reference to a class instance, to an object of type LCL car vehicle. So now we see create object statement, and you could just write create object LCL car vehicle, and then you get a car. So a car instanced into this variable. Sorry, now you would create car, and then because you know that the type is LCL car vehicle, you get an instance of this class. But you also can say I specify an interface type here, and any vehicle here is an interface type, and so because the system needs to know what real class it really needs to instantiate, you specify the class after a type statement. So the statement here says create object any vehicle type LCL car vehicle. Specify the interface type first and then the class, and then of course you can specify parameters because in this case the constructor has parameters. And now that you have a reference of type any vehicle, meaning of the interface type, you can just call refuel. And at this point here, any vehicle refuel, you don't need to know that there is an LCL car vehicle behind, or it could be an airplane, it could be anything. So this interface reference allows you to talk to many different classes, many different object types in a uniform way. So the interface basically gives you one aspect, one view on this class that is defined by the interface. Another way to do this is in the second example here, where you can take a reference to objects and convert them to interfaces. So you do a normal classical create object car, as I mentioned before. You used, in this case, the car vehicle is instantiated, LCL car vehicle, immediately, and you do a classical create object. And then you have a reference card pointing to a LCL car vehicle. Now, you know, the system knows that car implements the interface LIF vehicle. So you can now convert the reference of a car to a interface reference, any vehicle, which is of type LIF vehicle. And now any vehicle points to the same object, to the car, but it only kind of shows the aspect in the same way as before. It shows only the aspect of the IF vehicle, in this case only the refuel method. So if you have an object reference and it implements an interface, you can get the interface by just assigning it, like you do here, any vehicle equals car. And if you create object, right, you can also work with interfaces right away if you have, if you specify them on the create object directly. So here we can also, after we assign any vehicle, we can call refuel. Now we want to do another exercise where you can learn how to use interfaces. And the idea is here, the logical exercise is access different vehicle types via a common interface. So you start by copying the code from exercise 2 and changing it in the following way. First of all, you define an interface LIF vehicle which with the methods refuel, drive distance, and get current tank level. So you assume that these, from the logical perspective, should be the same for all vehicle types. And so basically you're kind of moving those definitions from the class into the interface. Then you define and implement a class LCL truck in addition to the car that also defines the interface vehicle. And also let the car that you already had implement the ILF vehicle. So then also you have to move the methods in the interface. You have to remove the methods from the car definition to the interface definition, of course, but you've already done that probably. And then remember the names of the implementation of the method. They were interface name tilde method names, so you have to rename the method names of the implementation that you already have. But this is all that's needed. If you keep the signature of the methods the same, then everything will work as before. And then in the reports in the main program, you can create several trucks in addition to the cars, drive some distances, collect references to all vehicles in an internal table. So you do this in main this time, and use it using the interface type. So you have a table of interface references, and then you loop over the table, checking that the tank level is less than 100%, and if it is, then you refuel them. So you will access all vehicle objects in a uniform way using this loop. So have fun with the exercise, and after that we'll also come back and do two more slides to look at some interesting aspects of this.